Students, we will today discuss about circular functions of a complex variable of mathematics paper first, number theory and trigonometry. This is chapter 8 of this paper. First, we define exponential function of a complex variable. When x is a real quantity, then we know that the expansion of e to the power x is equal to 1 plus x square by 2 factorial plus x cube by 3 factorial plus so on up to infinity, where e is the base of a natural logarithm and e stands for 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial plus so on up to infinity, whose value lie between 2 and 3. Similarly, this is for real quantity. Now we will take a complex number. Similarly, we define the exponential function of a complex variable z is equal to x plus iota y, where x and y are real numbers, as the series 1 plus z square by 2 factorial plus z cube by 3 factorial plus so on up to infinity, which is denoted by the symbol e to the power z, exponential z or e to the power z. Thus we have exponential z equal e to the power x equal 1 plus z square by 2 factorial plus z cube by 3 factorial plus so on up to infinity. Now we will prove an important result. To prove that e to the power x plus iota y is equal to e to the power x cos y plus iota sin y. By definition, we have the expansion of e to the power iota x plus e to the power x plus iota y is equal to, we will write expansion 1 plus x plus iota y plus x plus iota y का whole square by 2 factorial plus x plus iota y का whole cube by 3 factorial plus so on. Now putting x equal to 0, we have e to the power iota y is equal to 1 plus iota y plus iota y whole square by 2 factorial plus iota y का cube by 3 factorial plus so on. We will separate real part and imaginary part. This comes out to be equal 1 minus iota minus y square by 2 factorial plus y cube 4 by 4 factorial minus so on plus iota y minus y cube by 3 factorial plus y cube 5 by 5 factorial minus so on, because iota square equal to minus 1, iota cube equal to minus iota cube 4 equal to 1, or e to the power iota y is equal to cos y plus iota sin y. Therefore, e to the power x plus iota y is equal to e to the power x into e to the power iota y, which comes out to be e to the power x into cos y plus iota sin y from second. Therefore, the definition, it becomes the exponential function e to the power z of the complex variable z equal x plus iota y, where x and y are real numbers, is defined as exponential z is equal to e की power x cos y plus iota sin y. e की power x plus iota y equal to e की power x cos y plus iota sin y. When x equal to 0, we get e की power iota y is equal to cos y plus iota sin y. Properties of exponential functions. Product of exponential functions, that is index law. To prove that e की power z1 into e की power z2 is equal to e की power z1 plus z2, let z1 is equal to x1 plus iota y1 and z2 equal to x2 plus iota y2. Then by definition e की power z1 equal to e की power x1 plus write down the previous result cos y1 plus iota sin y1. E की power z2 is equal to e की power x2 and cos y2 plus iota sin y2. Multiply these two expressions e की power z1 into e की power z2 equal e की power x1 cos y1 plus iota sin y1 into e की power x2 cos y2 plus iota sin y2 is equal to e की power x1 plus x2 cos y1 plus y2 plus iota sin y1 plus y2. Because C stand for cos, I is for iota, S for sin. Cis theta 1 into cis theta 2 equal to cis theta 1 plus theta 2 is equal to e की power x1 plus x2 plus iota sin y1 plus y2, which comes out to be e की power x1 plus iota y1 plus x2 plus iota y2, and it comes to be e की power z1 plus z2. Journalizing the our result, we have e की power z1 e की power z2 into e की power zn is equal to e की power z1 plus z2 plus zn. Remark e की power z1 minus z2 into e की power z2 can be written as e की power z1 minus z2 plus z2, and z2 cancel both, we will get e की power z1. Therefore e की power z1 minus z2 equal to e की power z1 divided by e की power z2. To prove that e की power z whole power n equal to e की power nz, putting z1 equal z2 equal to z2 equal to zn equal to z in 1, we get e की power z whole power n equal to e की power nz. Periodicity of exponential function e की power z. To prove that e की power z is a periodic function with period 2 pi iota, तो z equal to x plus iota y, then by definition e की power z equal to e की power x plus iota y is equal to e की power z bracket cos y plus iota sin y. But we know that cos y plus 2n pi is equal to cos y, sin y plus 2n pi is equal to sin y, where n is any integer. Therefore e की power z equal to e की power x cos y plus iota sin y is equal to e की power x cos y plus 2n pi plus iota sin y plus 2n pi, n being any integer, is equal to e की power x into e की power iota y plus 2n pi. Combining these two, e की power x plus iota y plus 2n pi iota. Using the value x plus iota y equals z, we get e की power z plus 2n pi iota. Hence e की power z remains unaltered when z is increased by any multiple of 2 pi iota. Thus e की power z is a periodic function of period 2 pi iota. Now we will solve some examples based on the above discussion. Example 1, prove that exponential 2n pi iota equal 1, part 1, and part 2 is e की power plus minus iota pi by 2 is equal to plus minus iota. These are important according to examination point of view. Solution: by definition we know that e की power iota theta is equal to cos theta plus iota sin theta. Part 1, putting theta in this expression as 2n pi in equation 1, we have cos 2n pi iota is equal to e की power iota 2n pi is equal to cos 2n pi plus iota sin 2n pi is equal to 1. Putting theta equal to pi by 2 in 1, we have e की power iota pi by 2 equal e की power iota pi by 2 equal cos pi by 2 plus iota sin pi by 2 is equal to iota. Again, putting theta equal to minus pi by 2 in 1, we have e की power minus iota pi by 2 is equal to e की power minus iota pi by 2 equal cos pi by 2 minus iota sin pi by 2 is equal to minus iota. Hence, e की power plus minus iota pi by 2 is equal to plus minus iota. Example 2 is important. Split e की power z plus 3 iota का whole square into real and imaginary parts. Solution is 5 plus 3 iota का whole square. We will expand it. Is equal to 25 plus 3 iota का whole square plus 2 into a 5 b 3 iota, which comes out to 30 iota. Solving this expression, we will get 16 plus 30 iota. By definition, e की power x plus iota y is equal to e की power x cos y plus iota sin y. Therefore, e की power 5 plus 3 iota का whole square equal e की power 16 plus 30 iota equal 6 e की power 16 cos 3 theta plus iota sin 30 e की power 16 cos 30 plus iota sin 30. The real part of e की power 5 plus 3 iota का whole square equal e की power 16 cos 30 and imaginary part of e की power 5 plus 3 iota का whole square equal e की power 16 sin 30. Example 3, show that sin alpha minus theta plus e की power plus minus iota alpha sin theta की power n is equal to sin की power n minus 1 alpha into sin alpha minus n theta plus e की power plus minus iota alpha sin n theta. MDU 2019 and 16. Solution of this is left hand side is equal sin alpha minus theta plus e की power plus minus iota alpha sin theta all the power n is equal sin alpha cos theta minus cos alpha sin theta plus cos alpha plus minus iota sin alpha sin theta whole power n. Because e की power iota theta, this is fundamental result cos theta plus iota sin theta. this e की power iota theta equal to cos theta plus iota sin theta. We will further simplify it is equal to sin alpha cos theta minus cos alpha sin theta plus cos alpha sin theta plus minus iota sin alpha sin theta all the power n is equal to, we will use trigonometry here, sin alpha cos theta plus minus iota sin alpha sin theta. This second and third term above cancel each other, and it comes out to be, we will take sin की power n alpha outside from this expression, and remaining part is cos theta plus minus iota sin theta की power n, which comes out to be sin n alpha. We will use de Moivre's theorem, cos n theta power comes as a multiple plus minus iota sin n theta, and is one sin alpha we take inside, outside we will remain with sin की power n minus 1 alpha, and inside this becomes sin alpha cos n theta plus minus iota sin alpha sin n theta is equal to sin की power n minus 1 alpha, and this is sin alpha minus n theta plus cos alpha sin n theta plus minus iota sin alpha sin n theta, and this comes out to be sin की power n minus 1 alpha sin alpha minus n theta plus minus cos alpha. We will taken sin n theta common from this expression, above expression. We will get cos alpha plus minus iota sin alpha sin n theta outside. This comes out to be sin n minus 1 alpha bracket sin alpha minus n theta plus e की power, using the expression e की power iota theta equal to cos theta plus iota sin theta, then plus e की power plus minus iota alpha sin n theta. Then we'll stop here. We will discuss in the next lecture about